There's a star, far from Earth, that flickers like a dying candle. Sometimes dimming just a little, sometimes almost disappearing. No pattern, no rhythm, no obvious explanation. Astronomers had never seen anything like it. And for a moment, they wondered if it was something artificial, something built. Welcome to the mystery of Tabby's star, the strangest star we've ever studied. Tabby's star, or KIC 8462852, has challenged what we thought we knew about how stars behave. Its light dims unpredictably, sometimes by a few percent, sometimes by more than 20%. It's not a supernova. It's not a binary system. It's just weird. First discovered in data from NASA's Kepler mission, it became one of the most intriguing puzzles in modern astronomy. Because despite thousands of hours of study, we still don't fully understand what's causing this strange behavior. In this video, we'll explore what Tabby's star is, what's causing its dimming, and why, for a brief time, some thought it might be a sign of an alien megastructure. The year is 2009. NASA launches Kepler, a space telescope designed to find Earth-sized planets by watching stars dim as planets pass in front of them. Over 4 years, Kepler recorded the brightness of over 150,000 stars. Among them was one labeled KIC 8462852. Its light curve was unusual. Most stars show neat, regular dips when a planet passes in front, like a stopwatch. Tabby's star, though, was chaotic. Its brightness would dip by 15%, then nothing for weeks, then a 22% drop, the deepest ever seen by Kepler. This wasn't a planet, not even close. The data first caught the attention of citizen scientists in the Planet Hunters project, volunteers helping scan Kepler's data by eye. They flagged it as odd. Then a team led by astrophysicist Tabitha Boyajian dug deeper. Her 2015 paper put the star on the map. They ruled out instrument errors. The dimming was real. So what could it be? Scientists explored several natural explanations. One theory suggested a swarm of comets, a large family of icy bodies orbiting the star, leaving behind debris that occasionally blocks the light. But this theory struggled under scrutiny. Comets can't explain the depth of the dimming, nor its irregularity. Another theory proposed a disrupted planet. Maybe something collided with a planet or moon, and the debris cloud orbits the star. That could block some light. But again, not 22% of it. The numbers didn't add up. Others suggested interstellar dust, material drifting between us and the star. Dust can block light and would scatter blue light more than red, which is exactly what some telescopes observed. Still, even this explanation couldn't account for the long-term dimming trend, because yes, there's more. Data from earlier sky surveys, including photographic plates from the early 1900s, show that Tabby's star has been fading slowly for over 100 years. It's like watching a light bulb that flickers and dims but never quite turns off. So astronomers asked, what if we're missing something? And that's when a more radical idea entered the conversation. What if the star was being blocked by something built, not natural? In 2015, astronomer Jason Wright suggested that the dimming could match the behavior of a Dyson swarm, a theoretical structure that surrounds a star to harvest its energy. Not a solid shell, but a vast cloud of solar collectors orbiting in a loose formation. Science fiction? Yes, but worth testing. If an advanced civilization had built something like that, we might not see light signals, but we might see irregular dimming and infrared waste heat. So telescopes scanned Tabby's star across the electromagnetic spectrum. They found no radio signals, no unusual infrared emissions, no signs of artificial activity. Still, the hypothesis sparked the public imagination. and reminded us that the search for alien life is as much about eliminating the unlikely as it is about discovering the unexpected. Today, most astronomers agree that dust is the best explanation, but it's not ordinary dust. It may be a cloud of non-uniform, large-grain particles, possibly from broken-up exomoons or fragments of planetary rings. The dust orbits the star in an irregular, changing pattern, some clumps bigger, others smaller, explaining the chaotic light curve. But this doesn't fully explain the century-long fading. Some believe there are multiple overlapping causes. Short-term dust clouds combined with a broader disk of material slowly drifting across our view. Others speculate we might be witnessing the aftermath of a planetary system in decay, a solar system falling apart, leaving behind broken pieces and dust. The truth is, we don't know everything yet, and that's what makes Tabby's star so compelling. Tabby's star isn't just a curiosity, it's a reminder that the universe is still full of questions. It shows how citizen science, careful observation, and imagination can collide in the most unexpected ways. No other star behaves quite like it, and even if we never find anything artificial out there, the process of looking, of wondering, testing, and discovering is what science is all about. There are thousands of stars still waiting to be studied, and Tabby's star might just be the first of many strange ones. See you next time. Here's another one of our videos you can watch.